In this unit, we're going to look at what the solution to a linear inequality would look like. So to begin with, we're going to graph y equals 2x minus 4. Over here, you can see I've graphed it. Here's the y-intercept of -4, and it's got a slope of 2 up 2 over 1. So I've graphed that right here. What we want to do is do some investigation, and we're going to first choose a point that is above the line. So I've already marked this point right here. So here's my line. This is above it. So if I go on the line, I go up to go to it, so it's above it. So this point is the ordered pair 1, 3. So I'm going to write that here. This is the point 1, 3. Now what we want to do is we want to compare the left side, which is the y, to the right side, which is 2x minus 4. So y in this particular ordered pair is 3, and 2x minus 4, I'm going to substitute the 1 in. So I get 2 times 1, which is 2, minus 4 is -2. So if I compare the 3 to the -2, I can see that the 3 is bigger. So I would say that 3 is greater than -2 in that case, so it's bigger. So then let's look at a point then that is below the line. So here I picked one up high, so you can still see this is below the line. Here's the line. This is below it. So this one has an ordered pair of 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 7, 7. And again, I want to compare the y, which is 7, to plugging the 7 in here for my x. So it gives me 14 minus 4, which is 10. So comparing 7 to 10, I see 7 is smaller, so 7 is less than 10. And then for a point that's on the line, I picked this one right here, which is 4, 4. So I picked the point 4, 4. And so again, my y value is 4. My 2x minus 4 is 2 times 4 is 8. 8 minus 4 is 4 also. And this time my y is equal to 2x minus 4 when I substitute it. So when it was above, the y is greater than -2. When it's below, the y is less than the right side. And when it's on the line itself, the two are equal. So now I've written some notes here. A linear inequality can be formed by replacing the equal sign of a linear equation with an inequality symbol, such as less than or equal to, greater than or equal to. And the solution to a linear inequality is an ordered pair that makes the inequality true. All solutions are going to fall on one side of the line formed by the equation. All right, so let's do a little bit more investigation here. There's some facts. When the y value is on the left side of the inequality, so that's important. Notice up here when I did this, y is alone, so it's in y equals mx plus b form. Y is alone over here. So if that's the case, when y is on the left side, if I have a less than or equal symbol, there is going to be, because of the equal sign, there's going to be a solid line. The solid line indicates that the line itself is a solution because everything on the line is going to be equal. And I am going to shade, when I have a less than, I'm going to shade below the line. When I have a greater than or equal to, again, because of the equal, the line itself is a solution. So I'm going to indicate that by drawing a solid line. Every point on the line is going to be a solution. And I'm going to shade, because it's greater than, I'm going to shade above the line. And for a less than, it's going to be a dashed line, which means that the line itself is not a solution, but it's going to be the boundary line for the solutions, and we're still going to shade below the line. And if it's greater than, again, it's going to be dashed, because the line itself is not included, and we're going to shade this time above the line. All right, so let's use this. We're going to graph y is less than or equal to 2x minus 4. I see there's an equal here, so that means that there's going to be a solid line because the equal is there. And after I graph it, because it's less than, I'm going to shade below the line. So I'm going to graph, I have a y-intercept of -4, slope is 2. So I'll put it in, I've drawn my solid line, and now I'm going to shade below. So we shade it this way. So every point that falls below the line will be a solution to my inequality, and you can test a few to see how that works. So, throw in any of these points in there, you'll see that they test.